All right, welcome to the deep dive. Today we're going to try to tackle something that's really at the heart of how we design, build, and run the spaces we live and work in.
We're diving into BIM.
Yeah, building information modeling. And, chances are you've at least heard the term.
Oh, for sure. It's everywhere these days.
Right, but we're going beyond the buzzword. We're going to untangle what BIM really means, why it matters, especially in architecture, engineering, construction, and even in the world of managing buildings after they're built.
Absolutely.
What's interesting is, while BIM sounds all cutting edge, it's got a longer history than people might realize.
Yeah, its roots go way back, even to the 70s, in manufacturing and other industries. In the late 90s, you see it picking up in design and construction, and by the early 2000s, commercial software like Revit hits the scene.
So this isn't some passing trend.
Oh, not at all.
It's a real fundamental change in how things are done.
Yeah.
So where do we even begin with something this big?
Well, I think starting with the basics is key.
Okay, so let's get back to basics then. Our goal today is to cut through the hype and really understand what BIM is at its core, how it works across every stage of a building's life, literally, from the first idea to the day it might be torn down, and what's happening with BIM specifically in Canada.
And for that, we can turn to the Canadian Practice Manual for BIM. They actually give two really helpful definitions to get us started.
Okay, let's hear them.
All right. First, a building information model. What actually is described as unambiguous digital facility information used for communication and collaboration between every trade and stakeholder involved.
So we're talking architects, engineers, contractors, owners, operators.
Exactly. Everyone's on the same page using this digital information.
So it's not just a 3D picture, right?
Nope, it's a whole container of data everyone can access.
Wow.
Now, the second definition is about the process itself, building information modeling.
Okay.
This is defined as collaborative practices of creating, using, and maintaining models in support of the life cycle of a facility.
So the key word here is collaborative.
Absolutely. Working together and thinking about the entire lifespan of a building from the very first idea to maybe even demolition or repurposing, that's the heart of what makes BIM so powerful.
It's a long view. It's not just about design. So how does BIM actually play a role in each stage throughout that whole life cycle?
The Canadian Practice Manual for BIM lays this out pretty well. It starts with pre-design.
That very first stage where you're figuring out what the building needs to be.
Exactly, planning and programming. Then you move into the design phase, obviously, then construction.
Right, the building's actually going up.
But what's really interesting is the focus on operation and maintenance.
Which is the longest part of a building's life.
Exactly. And even when it's time for renovations, repurposing, even demolition, BIM is still relevant.
So it really is cradle to grave.
Truly is.
And I'm guessing that operation and maintenance phase is where building owners really start seeing the payoff for investing in BIM.
Yeah, that's when it gets very real for them. Imagine no more mountains of paper documents, your as-built, manuals, warranties.
All that stuff.
Gone. Instead, it's all in a searchable digital model.
So you could find the specs for a piece of equipment instantly.
Exactly.
Yeah,
That's a
but
massive boost in efficiency. It opens up possibilities for things like predictive maintenance and better energy management.
So you're preventing problems before they happen.
Exactly. Long-term value right there. Now, you mentioned earlier about a single evolving model.
Yeah, that ideal scenario where everything's connected.
It's a great goal, but in reality, things can get a bit more complicated.
Okay, how so?
Well, you've got different project delivery methods, concerns about liability, and everyone's using different software. It's not always a seamless fit.
So how do you handle that?
This is where the concept of dimensions in BIM comes in.
Dimensions, like length, width, and height.
Not exactly. Those are your basic 2D drawings, the first dimension, add geometry, and now you've got a 3D model, the second dimension. That's what we usually picture when we think of BIM.
Right, the visual model.
But it goes way beyond that. 4D brings in the schedule, showing how the building will be built over time.
So you can actually visualize the construction process.
Exactly. 5D adds cost information, giving you real-time budget tracking.
That's powerful. And it's all connected to that same model.
That's the idea. Then there's 6D, which brings in data for facilities management.
That's once the building's up and running.
Right. And some even talk about 7D, which might include things like sustainability or health and safety considerations.
It's like each dimension adds another layer of intelligence to the model.
Exactly. But with all these complexities, how do teams actually manage this in the real world?
That's a good question.
Well, the federated model is a practical solution. Imagine a collection of separate models, the architect's model, the structural engineer's model, the MEP model, and so on.
Each discipline has its own model.
Right. But they all come together in a common data environment, or CDE. It's like a central online hub where everyone can access, share, and coordinate these individual models.
So you still get that overall project coordination, but each discipline can use the tools and data that make the most sense for them.
Exactly. It's about finding that balance.
And the ability for all these different systems to actually talk to each other is crucial.
Right. Interoperability is the key word. It's the ability of different software applications to seamlessly exchange and, importantly, use that information.
No data getting lost in translation.
Right, and that's where open standards become essential.
These are agreed upon ways of formatting data so that different software can understand it.
Exactly. And Building Smart International is a big player in developing and promoting these open standards. It's about avoiding those productivity losses and errors you get with incompatible file formats.
So even if the architect is using one program and the engineer is using another, they can still work together smoothly.
And that's the whole idea behind OpenBIM, this collaborative approach that lets people work together regardless of their software. It's based on a commitment to open file formats and standardized data exchange, making sure everyone's speaking the same digital language.
Makes sense. Now, we talked about the model evolving through different project stages. How do you actually define the level of detail in the model at each stage?
That's where level of development, or LOD, comes in. It's a way to define how far along the design is and how reliable the information is in the model at any given point.
It's like a yardstick for progress.
Precisely. And it's communicated using a numerical scale, typically from 100 to 500. At LOD 100, you have very basic placeholders, just indicating something's there. By LOD 200, you've got approximate size, shape, and location.
Okay, starting to get more specific.
Then LOD 300 is where it gets really detailed, accurate geometry, quantities, the works. LOD 400 includes fabrication and assembly details.
So that's where you're really getting into the nuts and bolts of how it's built.
Exactly. And finally, LOD 500 represents the as-built conditions with verified manufacturer information. Knowing the required LOD at each milestone is critical for communication and planning. For example, a contractor could start prefabricating components off-site with confidence at LOD 300.
Saves time and avoids on-site errors.
Precisely.
It sounds like it requires a lot of effort up front in the design process.
It does. BIM is all about front-end loading. More decisions are made and more detail is worked out earlier on than with traditional methods.
So you're really laying a strong foundation.
Exactly. That initial design phase is crucial, and it's important to manage changes carefully because they can get really costly and time-consuming later in the game.
So for an architectural practice, adopting BIM is a much bigger shift than just learning new software.
Absolutely. It requires a fundamental rethinking of how they do business, their whole approach. The old way of handing off information, often on paper, is just too inefficient and prone to errors. BIM is about creating a much more integrated and collaborative environment.
And that could even mean architectural firms needing to rethink what they offer and how they provide value to clients.
For sure, they might need to explore new ways of working with engineers, contractors, even owners right from the start. Their value proposition could become more about their expertise in managing information and coordinating the model on top of their traditional design skills.
So how does an architectural practice actually make that transition to BIM? It's obviously a huge undertaking.
It is, and the first thing to remember is that it's not just about buying software.
It's a whole organizational change.
Exactly. It affects processes, technology, even the roles people have on the team. Strong leadership is essential. Everyone needs to be on board.
You mentioned changing roles. What new positions or responsibilities might pop up in an architectural firm that's adopting BIM?
Two key roles you often see are the system integrator and the BIM manager. The system integrator focuses on setting up data exchange protocols, standards, the whole technology infrastructure so that all the systems talk to each other.
Make sure everything's connected.
Right. The BIM manager usually works on specific projects. They make sure the model is configured correctly, everyone's following the BIM standards, and they support the project team.
So it's really about facilitating this new data-driven way of working.
Exactly. And when you're hiring new staff, it's not just about technical skills anymore.
People skills are just as important.
Absolutely. BIM is all about collaboration, so communication, teamwork, and being able to support colleagues in adapting to new ways of working. Those are all critical.
So a well-structured training program is crucial for BIM implementation.
Absolutely. It needs to be a systematic approach. First, you analyze what the firm needs and what their goals are. Then you design the learning experience, develop the materials, implement the training through different methods like workshops, online courses, project-based learning, and then evaluate how effective it's been so you can make adjustments.
And this isn't a one-time thing.
No, it has to be ongoing. Technology and best practices are always changing, so you need introductory training for new people, ongoing learning to keep skills sharp, regular reviews of the firm's BIM standards, and continuing education for BIM leaders to stay up to date.
It's like any profession, you have to keep learning.
Exactly. And the training works best when it's tied directly to current projects, so people can apply what they've learned right away. Key things to cover for smooth operations often include network configuration, how to build models, setting up drawings from the model, and project planning in a BIM environment.
So training should be tailored to how the firm actually works.
Absolutely, aligned with their overall plan and what they offer to clients. Okay, let's shift gears a bit and talk about the technology behind BIM. What about the software and hardware?
What are the big considerations there?
Well, BIM software generally supports four main functions. There's authoring, which is creating and modifying the model. Then there's analysis, which includes things like simulating energy performance or structural analysis.
So you're testing out different scenarios virtually.
Exactly. Then there are construction applications for sequencing tasks and fabrication. And finally, management tools for running the building and doing maintenance.
Okay, so it covers the entire building lifecycle.
It really does. Now, on the financial side, firms have to decide between subscription-based software licenses and perpetual licenses.
So paying a recurring fee versus buying it outright.
Right. There are pros and cons to each, considering upfront costs and ongoing maintenance.
And we talked about the importance of different software working together seamlessly.
Absolutely. Choosing software that adheres to open BIM standards is crucial for that interoperability and smooth collaboration.
So that commitment to open standards leads to greater transparency, a shared language for procurement, and ensures project data is accessible throughout the building's life.
Exactly.
Now, what about the actual computers that run this software? Those models can get pretty big, I imagine.
They can be huge. And while computers are more powerful than ever, the demands of BIM are constantly pushing the limits, especially with complex visualizations and data management.
So you need some serious processing power.
You do. A good rule of thumb is to invest in processors with high capacity and dedicated graphics cards that can handle the visual side of things efficiently. You want hardware that's powerful but will also last.
And with people often working remotely or in different offices, communication technology is essential for BIM too, right?
Absolutely. You need a strong network infrastructure and enough bandwidth to handle those large model files and project data being exchanged.
Yeah, so you might have a local area network within an office, a wide area network for firms with multiple locations, VPNs for remote access.
And increasingly, we're seeing cloud-based platforms. They offer scalability and accessibility, but you have to be mindful of security and how your data is managed.
And things like video conferencing and instant messaging are crucial too, right?
Of course, keeping teams connected and having those real-time discussions is so important.
It's becoming clear that BIM is as much about efficient workflows and a collaborative culture as it is about the technology itself.
You hit the nail on the head. The real value of BIM comes when it's integrated into seamless workflows, connecting all the different project stages and stakeholders.
Which is a big shift from the traditional siloed way of doing things.
Exactly. And the firm's culture plays a huge role in how well they can adapt to these new, more collaborative ways of working.
And changing an established culture is no small feat. How can firms encourage a BIM-friendly culture?
It starts at the top. Leadership needs to be fully committed, showing that BIM is a strategic priority for the organization. Then they need to back that up with resources, training, technology, ongoing support.
So people know it's not just a flavor of the month.
Right. Having a clear plan for the transition, explaining the benefits of BIM, addressing concerns head-on, those are all key. Open communication and celebrating successes along the way can really help build momentum too.
Now, to manage all of this on a specific project, there's this crucial document called a BIM execution plan.
The BXP. It's basically the project management blueprint for how BIM will be used and managed on that specific project. It can go by different names, but its purpose is always the same.
So it's a tailored strategy for how BIM will be used on that building.
Exactly. And it's a living document. It evolves as the project goes along. Usually, a BXP will have sections outlining project information, the specific BIM goals, how BIM will be used to achieve those goals.
For example, using 3D coordination, to prevent clashes and reduce those requests for information during construction.
Exactly. It'll also include detailed process maps, information exchange protocols, data requirements, collaboration procedures, quality control measures, the technology platforms being used, the model structure, and the deliverables.
So it covers all the bases.
It aims to, and having those project goals clearly defined is essential. If a key goal is energy efficiency, the BXP might outline how you're going to use energy modeling and analysis at specific points in the design.
So everyone knows why they're using BIM and what they're aiming for.
Precisely. Now, for our listeners in Canada specifically, who are some of the key organizations supporting BIM adoption?
What's the landscape here?
There are a few important players. There's Building Smart Canada, or BSC, which is the Canadian chapter of Building Smart International. They're focused on developing and implementing Canadian BIM standards and promoting interoperability.
So keeping things consistent across the industry.
Exactly. Then there's the Institute for BIM in Canada, or IBC. They have a broader mission to lead and facilitate the coordinated adoption of BIM across the entire AECO community.
That's architects, engineers, constructors, owners, everyone involved.
Right. Their priorities include advocating for open BIM standards, promoting collaboration, developing best practices, providing training, and keeping everyone in the industry connected.
Sounds like they have their hands full.
They do, but it's important work. And then there's CanBIM, which acts as a voice for the digital technology sector within the Canadian AEQ industry. They advocate for the industry, provide learning opportunities, and offer guidance on best practices.
And can BIM and Building Smart Canada often work together, right?
They do, which is great to see.
So there's a strong network of support and resources for people in Canada who are working with BIM. Are there any specific resources our listeners should know about?
Absolutely. The IBC has developed some really valuable resources. They have a contract language documents package, which includes a BIM contract appendix that can be added to standard Canadian construction contracts.
So that helps clarify legal and contractual aspects of BIM, things like copyright and model ownership.
Exactly. They also have the IBC BIM PXP Toolkit package, which offers templates, guidelines, and other resources to help project teams develop their own BIM execution plans for different project phases.
So sort of plug-and-play system for project management.
Exactly. And lastly, there's the roadmap to lifecycle building information modeling in the Canadian ATO community. It's a comprehensive document outlining a strategic path for the industry's transition to BIM through collaborative approaches and aligned standards.
So a guide for how we get there. Well, this has been a truly in-depth look at the world of building information modeling. To sum up, we've explored how BIM is a collaborative process using digital models across the entire life of a building. We talked about the crucial role of interoperability, those open standards, the phased approach through the BIM lifecycle and levels of development, the organizational and cultural shifts needed to implement BIM successfully, and all the resources and organizations supporting BIM right here in Canada.
It's a really significant change that's reshaping not just how we design and build, but how we collaborate and manage information in the built environment. It makes you wonder what future innovations might come out of this increasingly sophisticated digital foundation.
Absolutely. If you're intrigued by this world of digital building, and you want to hear more about how technology and collaboration are changing our physical spaces, be sure to subscribe for more deep dives into this fascinating world.